Hi, welcome. This video is going to be covering 5.35, the empty set and all real. So many of you are in the section of 5.3 and saw at the end of that lesson there was a section on the empty set and the real set. So I decided to make a video just on the empty set and the real set. That's why I call it 5.35. But there's really no 5.35. This is just another part that I just included there because I just want to give you more details on the empty set and the real set, okay? Alright, so let's start this off by connecting to your prior knowledge. And I'm going to have you review by doing this problem. Solve this equation, 9t minus 5 parentheses t minus 5 close parentheses is equal to 4 parentheses t minus 3 close parentheses. So please pause this video and attempt to solve this problem. Remember again, this is a multiple step equation. What I'm asking you to do is solve this equation. So get t alone. Please pause this video and work on it. Alright, so now here I'm going to be covering the solution for the problem that I just asked you to attempt. First step is always to rewrite the original equation. And what I'm gonna do is I'm gonna distribute the left hand side. So negative 5t becomes negative 5 times t is negative 5t. Negative 5 times 5 is positive 25. Notice that I bolted that part that I distributed in to give you a better visualization. Now I'm going to distribute the right hand side. 4 times t is 4t. 4 times negative 3 is negative 12. Again, it's bolted because I'm showing you the distributive step. Normally your book shows this in one step, but I want to show it into two steps so you can see all the work that is being done. Combine the like terms because on the left hand side I got a 9t and I got a minus 5t. So 9t minus 5t becomes a 4t. That is my combining like terms here. Right? Okay. After that, I subtract the 4t to both sides because I'm trying to get the variable alone. I've noticed that on my left hand side, 4t minus 4t becomes a 0. So all I'm left with is a 25 equals to negative 12. Because the variable disappears, 25 is never equal to negative 12. I would say that this has no solution. Alright, so what happens if it's an inequality now? Solve this inequality. You should notice that these are the same expression on the left hand side as is on the right hand side, but this time the equation is now an inequality. So please pause this video and do the problem. Alright, so this is going to be the solution. Again, the work is exactly identical as to before, but this time it's not an equation, it is just an inequality. Again, I'm not going to go over step by step because it is the same step as before. You should notice that in the end it was 25 and that the inequality here is less than or equal to negative 12. So the final answer is the final answer has the same expression on the left hand side as on the right hand side like before. You have a 25 on the left hand side and a negative 12 which is on the right hand side. So do we say that there is no solution like before? No. We actually say the solution is the empty set. Okay, we do not say no solution. We say that the solution is the empty set because remember, an inequality gives you a list of numbers or a set of numbers. In this case, we say the solution is called the empty set. So, what is the empty set? Let's start off with the formal definition. In set theory and in higher mathematics, the empty set has a different definition, has a better definition. The empty set definition that I'm giving you now is very basic and very cut from the real chunky definition of it, but this is all you need to know about the empty set. So the empty set's definition that we're going to be using is a list of values that contain nothing in it. That is why it's called the empty set, because there's nothing in it. We also call the empty set the null set, because null is what empty is. Okay. So the symbol that you can use is just the fancy bracket with nothing in it, right? It's empty, and or the 0 with a slash going diagonally down on it. The empty set does not contain 0 in it. 0 is something. Remember that the empty set contains nothing. So there is a difference between 0 and the empty set. People believe that the empty set contains 0. It does not contain 0. It contains nothing in it. Remember that 0 is something. It is still a number. It's 0. It's between 1 and -1. But the empty set contains nothing in it. Okay? That's why it's called the empty set, or because there's nothing in it. Alright, so let's connect to your other prior knowledge. Review this problem. Solve this equation. 3 parentheses 4m plus 6 close the parentheses is equal to 42 plus 6 parentheses 2m minus 4 close the parentheses. Please pause the video now and attempt to do the problem. Let's go over the solution for that problem. Here's my original equation. I'm going to distribute the left-hand side. 3 times 4m is 12m. 3 times 6 is 18. That is what's happening on the left-hand side. Let's distribute the right-hand side. 6 times 2m is 12m, and 6 times -4 is -24, because 6 times -4 is -24. Then you want to combine the like terms. Do you see how there is a 42 minus 24 here? That becomes a positive 18. Notice that 12m plus 18 equals to 12m plus 18. We call this infinite solution because the left-hand side expression right here, it matches with the right-hand side expression. We call that infinite solution. So what happened if it's an inequality? Solve this. It should not say equation. It should say inequality. Please solve this inequality. Please pause this video and attempt to solve the inequality. Many should already notice that this is like before. So let's do the solution. Like the problem that we just did in connecting your prior knowledge. This is exactly like the problem before. Your answer is sort of the same. Your left-hand side expression, 12m plus 18, matches with your right-hand expression, 12m plus 18. You see that the left-hand side of the expression matches with the right-hand expression. The only difference here is that this is no longer an equal sign. It is all an inequality symbol. It is less than or equal to. So, like before, when we had this as an equal, right, 12m plus 18 is equal to 12m plus 18, we call that infinite solution. In this case, that it's an inequality, do you think that there is infinite solution? We actually call it something else. We say that the solution is the set of all real numbers. So, before, when it's an equation, we say infinite solutions. But for an inequality, if it's the left-hand side is equal to the right-hand side for an inequality, and an inequality solutions are a list or a set of numbers, we say that the solution is a set of all real numbers. Oh, this should not say what is the empty set. So, what is the real number set? Okay, what is the set of all real numbers? It's a list of values that contains all the real numbers, right? It's also called all real. Some people do not write set of all real numbers. Some people, and the book uses all real. There is no symbol for the all real or the sets of all real numbers. So some of you are wondering, what is the set of all real numbers? So you have your natural numbers like 1, 2, 3, 4, 5, your whole number, which is 0, 1, 2, 3, 4, 5, go on positive infinity. Then it's your integers, which are your negative numbers, 0, and your positive numbers. Okay. You get your rational numbers, which is like your fractions, like 1/2, 1/4. Then you get your irrational numbers, right? Numbers that go on forever, like pi, square root of negative 3, square root of 5. Okay? So all your real numbers are these numbers right here. Okay? Imaginary numbers, you won't see this until you get to IM2 or IM3. You don't get into imaginary numbers until that course, but they have an I next to it. These are called imaginary numbers. So, right, math is broken has two um, sides here. You could have all the real numbers, then you have these imaginary numbers. For this problem, okay, when we say the left hand side is equal to the right hand side, any value of n that we plug in is going to be a solution, whether it's a rational number, irrational number, zero, a whole number, a negative, a positive integer. It doesn't matter, right? As long as it's still a real number, that inequality should be valid. It is not valid if we use a imaginary number. Okay, so that's what the set of all real number visually means. Okay, now I would like you to do the guided practice. You're going to solve each inequality, 5a and 5b. Please pause this video now and attempt to do the problem. Alright, let's go over the solution for the guided practice. 5a, that's 5a. First step is always to rewrite the original inequality. I'm going to distribute the left hand side. Negative 3 times 8c is negative 24c. Negative 3 times 4 is negative 12. Then you're going to distribute the right hand side. Negative 6 times 4c is negative 24c. Negative 6 times negative 1 is a positive 6. After I distribute, I'm going to combine the like terms. So there is an 18 minus 12 here. So there is a 6 left over on the left hand side. Then 24c plus 6 is greater than negative 24c plus 6. The left hand side expression here matches with the right hand side of the expression right here for the inequality. So, because the left hand side expression matches the right hand side of the expression for the inequality, we say the solution is the set of all real numbers. Set of all real numbers. 5b. Start by writing the original inequality. Distribute to the right hand side. So negative 4 times 2m is negative 8m. Negative 4 times 5 is negative 12. That's what happens after you distribute the right hand side. Then you want to combine the like terms. 8m minus 8m is 0. That's how I got the 0 here. So when is 46 less than or equal to negative 20? This doesn't make sense because the variable here disappears. So we wouldn't say we wouldn't say that, there is a solution. We would say the solution is the empty set because there is no list of numbers that we can plug in here that would make this valid. Okay? So this makes no sense. That's why the solution is called the empty set. There's no value that you can plug in that makes this valid. Okay? And there you go.